Hi everyone, welcome back to my channel. Unfortunately, I record this video, but it was with no sound. I have no idea why, but I'm just retry now to record it again. So in today's video, I'll try to show you how to, show you the main aspect, or let's say essential aspect of machine learning workflow, which is how to train your model using machine learning, Azure Machine Learning via the CLI Agent 2. So we will cover everything from set up the job, explaining the training pipeline code. I will try just to explain my code a little bit. It might be not relevant for you, but yeah. And also the commands and everything. So the previous video, as you can see in this image here, in the previous video, all of these components, I have uploaded videos how to create each of these components in four different ways, either using the website Azure portal azure.com, using CLI Agent 2, using Python SDK Agent 2, and the most important, if you would like to make it automatically through the Azure DevOps pipeline. So in today's video, I will try, as I said in the beginning, to use the CLI Agent 2. So let me just go to the code. Okay, unfortunately, as I said, the video was recorded without voice. Okay, and let me just start from here. If you are familiar, let's say, with machine learning, and you run it in your PC, so what are the main essential parts you would like to do if you would like to run any algorithm? So I will see a PC, of course. You need a PC. You need environment, which is install all of the packages in your PC, including if you are using Python, including I don't know, the algorithm are using PyTorch or TensorFlow, any other algorithm, Skyline, and also the third one is the code. You need code. So review. You need a PC. You need code, and also you need of course, you need the data. Now, if you would like to run in the cloud, in Azure DevOps Cloud, I'm assuming that you're already familiar with all of the previous stuff. I mean, this components. I have uploaded all of these. The videos on each component, how to create it, and I'm assuming also you are familiar with this. Now, to run this code in your Python, let me just put it here. What is this? Black. I know. To run the code in your Python, what you can do, let me just clear this. So I'm just assuming that you are in your PC. Forget for a moment the Azure pipeline, the Azure machine learning. So what you can, Python main, let's see, .py. Now this will run this file here and also the relevant codes. But if you would like to run this in Azure machine learning, so you need to use this command using CLI if you use CLI. So I will show you what are the parameters, help, what are the most important parameters for this. And okay, maybe see it's slow. Uh-huh. Okay, as you can see here, Azure machine learning create a job. So to create a job, you will typically need a configure any code to run. Of course, you need a code. You need environment, you need a compute, and any additional job specific settings. This is we let's see usually need. And to this is the main arguments, the required file. You can see the sample of the required the YAML file, job YAML file in this link, and you can see the syntax is schema, the type of the it's needed here for instance. See, it's required, and the name of the job, the display name, the tags, the jobs, and also input, output, and also the compute. Where's the compute? It should be here. Yeah, the default compute. Now this is the main. Let's see over this is how much how overview, quick overview. Now this is the file. So now we need to create this file here. So I already prepared this. So you can see this is the file. We have to add the schema. This is, I mean, you can just copy this sample and you have to adapt it to your needs. And the type is command, and the command is this one here. This command will be run in the cloud. So I will try to run my Python code, which is this one here. And the input, I need some input, which is the data. And if I'm running this in my PC, I will use this data here. If not, I will use the specified here. You can see input dot input data, and the type is URI file, and the path is Azure fruits data asset 1. The version is 1. So I can show you with this. Okay, let me go to the. So now I'm using the uh, workspace demo pipeline 03, and you can go to data, and you have also the data stores and everything. Now you can see data assets. I'm using this data assets, and here's the versions of the data. If you have different versions, all of these already explained in the previous video, so don't worry. So let me see, I'm using version 1, and you see here named assist URI. Just copy this name. If you would like to use the version 1 fruit data asset version 1, just copy this. If you would like to use any other versions, if you have in your PC, I mean in this data assets, just change the version. And what I have, what you have to do is just copy this and put it in the path of the dataset. So this is our input. Now the model name, you can either add it as a parameter here, inputs, and use the parameter here, or you just make it as a fixed. Let's see here. And sorry, and the output parameter is output. This is where the output of our training model and other, let's say for instance, the matrices, logs, and any files you would like to save in the cloud. And this is the final path. It should be in a data store files. I mean data store fruits and fruit model. And I will see the most important all of this of course important, but the environment you would like now to use environment, Anaconda environment. In your PC you need to use Anaconda or Beauty. For instance, I'm using here Beauty in my project. I also uploaded a video on how to install and use Beauty. Now let me just see, I have this package, where this package is. So where to find this this environment. So go to the environment. I mean, this is the workspace. So go to light. This, for instance, I have looked for this, and this is the version of different. They have different versions, but let me just see. I'm using GMB light GMBM, right? And let me just go to my code. So, and you can see here, for instance, this is Panda. I need Panda. All of these, for instance, all of these are default already installed in Python. Now I need Panda job MLflow, and this is my code, of course. This is installed built in. Now I need, let's see now to create environment. But before creating your environment, try to see if this the environment is already provided in the Azure ML. So if it's already there, you don't need to repeat your work just to keep your time. So for instance, this is I'm using Light GMP. It has all of these dependencies, all of these packages, and everything here I need. It's already defined here. So you have to compare. You have to check. Do you would like to have, let's see, any other package, or maybe you need different Skyline different version. So if you would like to use different version, this won't be applicable for you, or let's see, helpful for you. So you can, so what you can do. So the solution for this, if you don't have, if you would like, if you don't use, because before this, I just need to show you light. Let's see this one here, and you just need to copy this name. Yeah, this access ID. Just copy this and use it in your environment, in your job file. You can see, let me just copy this, see if it's the same. Right, so you need to copy this link. I mean, you don't need to look where is this, just copy the link, the whole link from here as its ID, and will be fine for you. Okay, let me just, and this is the jobs that already use this package, because I have many jobs here using this environment. Sorry, I'm confused between package and environment. Okay, and if back to this environment, if you would like to install your versions, your specific packages, or I don't know, you can use this environment, your environment name, conda file might be, let me just see, maybe this one here, depends on your needs. And also you need to identify the image, Ubuntu 20 or Ubuntu, I don't know, depends on your needs. Okay, and now, as I said, we need also to have a compute. Where's my compute? Where's to create a compute? I have also uploaded 4 videos on how to create with different 4 different ways how to create a compute cluster. So in my case, I have a different compute cluster. Why it's giving to this directory, but I will close this. So in the compute, you can go to compute clusters, and this is my cluster here. I'm using this cluster. Or it's called BC, but cluster, it means to maybe many virtual machines. And I would like to identify the code. Where is my code? So here I'm starting Python main.py. But where's this file? So now I'm in this directory. I'm now in this directory. Where is main related to this? It will be in the above directory, in one directory above. So that's why I add double dots. And here, this is the description, and this is the data. Let's say experiments. Experiments. Let me just, maybe you can just change it like this. And now I will go to main, just copy the command, copy, no, copy, then return it back. So I will just click here, hit enter, type it here, or just copy paste. All of these, don't worry, all of these commands and everything, it will be loaded, already loaded in the GitHub repository. And here you can see how to create compute and with Python, and how to create a container, and everything here is already explained, so no worries. So now this will try to create a job for us. So where's the jobs? So I will show you where's the jobs. You can see here, go to the dashboard, main dashboard of the your workspace, click jobs, and you can see this is my previous jobs. So now I have defined my job will be X expects this one by experiments by adding S to this variable. So I will just click here, refresh, might be created, not yet. Oh, it's already created. But let me just show you the specification of this. After running this, it will show you this YAML file. So the user that they created by blah blah blah, and this is my uh, Sele Mango. This is the job name. It will be created job name, and it will be in this one here, fruit training XPS. And let me just see, now make a refresh. Yes, so now it's created. You can see here it's created, but it's a queue, and you can see silly mango. It was found in this one here, silly mango. Yeah, this one. So now this is now creating our job. So the next step in this, it's also doing this, is to make the your training model. It will do the training and save the model. If everything is perfectly correct, it will save the model in the models here. But we will see this. Yeah, because this will take, let's see, somehow time. Let me take this time and show you what is written in my code. So you can see here, I have to train I have to classify the fruits, data sets. Where is the data sets? You can see here, this is the data is downloaded from Kaggle, and here's the class label of each fruit. And the most important, let's say, stuff. You can use whatever you want. This is not, let's say, restriction to use this algorithm. It depends on your needs, indeed. And if we run, you can see here I start with MLflow start run. So MLflow, it's a good uh, package to track your input, output, and everything. As you can see here, I'm tracking also the parameters. So the model will be will be saved, right? But uh, you might, let's see, next week you will forget which parameter did you use. So this is a good practice to save your parameters. So, and this is splitting the data into training and testing. This is doing the training with specific parameters. This is the model. We also try to evaluate. I mean, you can go even to evaluate to see the evaluation model and calculating the accuracy. If it's, for instance, two classes, it will go here. Different classes will be here. If it's interesting for you, you can have a look. I will also put this in the Git repository, and you can see after calculating the accuracy, the any matrices, it will be also logged in the matrices. And after that, I mean, the most important one, we will save also the model itself, right? And this is not used. That's it, I think, for this. So of course I will upload the code, the parameters, the everything. You can see it in the my GitHub, and you can adapt it to your example, for instance. Let me just go. Okay, it's still queuing, it's still running. Now it's running. Our job is running. You can see matrices, nothing because it's still running. You can see the logs, the code, yes. So why now it's our code is here? Because we have in the job we have said the main, this is the main file, right, in this here, and we see with our code, we see our code in this directory, it means in this directory. So it will try to copy all of these, and you can see, of course, all of these files, sometimes oops, sometimes you have an ignored file, for instance. This will be in ignore, so it won't be uploaded. And I think you can see completed. So let me just go back. Now you can see our job is completed, and you can see this is our parameters for this algorithm. As I said, in this file, in the main file, we have said log params. It will log all of these parameters, and these parameters are in this one here. It will be read by YAML file. It will be read by load parameters. And also you can see this is the matrices, the accuracy, the AUI for the class, this one, and etc. And you have here, you see the Git repository. It use this one here. Of course, now the code is in Azure DevOps, but of course I push it also in the GitHub. You can find it in the GitHub, and you can see the register model already registered the model. It's final fruit final model version 7, and you can see the computer cluster was used here. Number of instance was because if you have a big data, let's see, you can expand or scale the cluster to several nodes or several virtual machines. And let me just see the matrices, metrics or matrices, doesn't matter. And this is the output. And what is the images here? We have no images. So the images here is, let's say, assume you draw the plot of the confusion matrix or AUI curve on or any other stuff you would like to plot, do the plot or figure. It will be submitted here after tracking with MLflow, of course. And this is no child job, and this is the logs, and this is the most important one here. You can see this is our outputs, which is defined in the main in the job file, job YAML file. We have the outputs here. For the for the output, forgot to tell you. Maybe it's with it's not here. Okay, with this, and you can see it's also, by the way, MLflow will try to give you what are the packages are used in your experiment. For instance, MLflow, which version, and everything will be written here. So, and this is the requirements if you would like to use the requirement files. And this is the Python environment YAML. You can also create it, create environment if it's if you would like to use requirements, for instance here. And you can see ML model. This is the work MLflow outputs. Let's see artifacts. So you can see it will use Kunda, this file. Oh, it's selected. Okay, it's by default. Ah, no, I have just to close it. Yeah. So you can see I will use Kunda. The visual environment will be using this one here. And the loader model, it will MLflow, it will load this one here, backend file. The path is this one. And if the other parameters, let's see, it will be, let's say, needed. And now after running this job, so what I have to do with this model here. So before going to what I have to do, if you check your models now, your model will be registered here. So you can now use, for instance, you can just see the versions of your model. You can see I have seven versions. The last one was deployed, created now I think 5 minutes before. And this is the artifact. The endpoints it's not used anymore. This is the jobs maybe auch. It's still auch not used. Feature set and other parameters. But in the next step, we have now our model. In the next step, we will try to set up endpoints that we can train our model with real-time endpoints or batch endpoints. But until this, I will try to, of course, show you this how to do it. And one important, let's see if lesson will be in the next. It will be how to do all of these. I mean, instead of using the YAML file, I mean, writing the command here manually and do everything here. So I will try to show you how to do all of this automatically in Azure DevOps pipeline. So that's it for today. We have successfully trained our model, our machine learning model in Azure Machine Learning using CLI version 2. And if you found this tutorial helpful, please don't forget to like, subscribe, and comment below. If you have also any question, try to write it in the comment below. I will try to solve it, of course, if I have time. Thanks for watching and see you in the next video.